Okay, so this question says, is a statistics class delivery type a factor in how well students do on the final exam? The table shows the average percent on final exams for several randomly selected classes that use the different delivery types. So, for example, we have a face-to-face class, and here's some of the different scores from some of the students who took a face-to-face stats course. And then there's a hybrid. Hybrid means a mix between face to face, some online, some face to face. There's how they did. There's their exam scores, and then there was an online, purely online, no face to face at all, and there's their final exam scores. So the question is it a factor? In other words, does it make a difference? Are these numbers in the top row kind of the same as the middle, kind of the same as the bottom? Is face to face, hybrid, and online all have kind of the same results, or does it make a difference? Are they different? Are they all kind of the same, or is there a difference? All right. Well, what is this? I mean, what kind of a test is this? Well, if you go to the notes, you'll see that this is an ANOVA test. Now, it doesn't say ANOVA. How do we know? Because it's 3 or more populations. Notice everything else we did was 2 groups or 1 group. We've never done 3 groups before. At least with averages, I should say. You might say we've done 3 groups in a big old data table. Yeah, not for averages. 3 averages, mean, having that, mean is average, right? So these are 3 averages. These are the average score. So we're wondering, is the average for this group, is it the same as the average for the second group? Is it the same as the average for the third group? That's what we're wondering. How do the averages compare? The average percent on the final exams for these 3. So whenever you have 3 or more groups, could be 4 groups, 5 groups, whatever, and you're talking averages, means, then you have to use what's called ANOVA. ANOVA stands, I don't know if you care, analysis of variance. So what it's all about, it comes from the words, it's a shortcut for analysis of variance. It's an acronym, I guess, for analysis of variance. So that's how you handle, how you going to recognize this on the final when it's mixed with everything else. 3 or more groups, averages. 3 or more groups, averages. Then that's enough, because we've had almost everything we've done is 2 groups or 1 group. Now we've done a couple of things that have 3 or 4 different groups, but it's not averages, it's just number of people. We've had some sports problems like saying, do you like tennis? What's your favorite sport? Tennis or swimming, or I can't remember the other one. Tennis or swimming or soccer, I think it was, and we'd have 3 different groups, and we'd have people 18 to 25 and 26 to 30. And, there was a lot of groups there, more than 3. Yeah, but those weren't averages. Those were like 10 people here and 12 people there and 13 here and 7 here and 9 there. Except those were number of people. It wasn't averages. There weren't averages anywhere. Whereas these are averages, right? They're asking us about averages. They're saying, is the average percentage on the final exams from several randomly selected classes. So this 92, that's the average score for that class. These are 9 different classes. Their average score in the final, that's a high score in the final. Average is 97, 67, 64. These are averages. So when you're talking 3 or more groups and averages, you got to use ANOVA. So you got to recognize that. So 2 groups or less, those are the other tests: homogeneity, independence, goodness of fit, lots of other things. But if you're talking 3 groups or more and you're talking averages, it's ANOVA. So we go, okay. Now there's one way or 2 way. This is just one way ANOVA. Why? Because we're just testing whether 3 or more populations have the same mean. 2-way ANOVA is if you're testing whether 2 different factors affect an outcome. They'll be really specific about that when they ask you about 2-way ANOVA. So this is 1-way ANOVA. We're just testing whether 3 or more populations have the same mean. That's exactly what they say. They say, is the average for the finals, is delivery type a factor? Is the average, are they all the same, or is the averages all the same, or are they different? That's what we're testing. All right. So once we got that straight, we go, okay, the HO is 3 or more populations have the same mean. All the groups have the same averages, or at least one of the groups has a different average. So notice This is saying all the same because they're all equal. See how they're all equal there? All the same. And this says at least two of the means different. So HO is all the same, H1's different. All right, let's dive in. This study, we need ANOVA. We went through that. So now it's time to get the test statistic and p-value. Get that from the calculator. Where are we going to go? No big surprise, online calculator, ANOVA. So we're going to go to ANOVA. Let's go there. So here's the online calculator. ANOVA is the last one, the very bottom. It's the end of the online calculator, number 25. ANOVA. We've reached the bottom of the barrel. 25. ANOVA. So click on that, and it has a bunch. You can put in a bunch of different data. So we're just going to copy and paste and put in commas. So let's go back. Let's go find the numbers, copy and paste them, and put them in. There they are. So I'm going to grab them. Okay. Grab the first row, face to face, copy, and paste it in this top row. And put commas between them. Don't need to fix the spacing, as you know, just take the commas between them. All right, let's go to the second row. Copy the second bit of data and into the second go. And put the commas between them. And finally, data table 3. Let's go there. Copy the third and last row. And put them in there. Put commas between. All right, there we go then. So that's it. So we've got that. And now we got all that data pasted in. Just come down the bottom. Hey, calculate. Calculate. There we go. There's what's called an F value and a P value. We're used to the P value. They're going to want both the F value and the P value. P value is 0.3749. Let's go back. 37. Yep, there it is. P value 3749. This is what they call the F value. That's the test statistic. And the P value is what we really care about, 3749. Okay. So now you know what to do from here. Let's wrap it up. So the P value, 3749. How does it compare to alpha? What's alpha on this one? 0.01. So alpha is 0.01. So 0.01, this is 3749 is the P value. So that 37 is obviously much greater than 0.01. Much greater. That's why it's greater than alpha. So what does that mean we do? You know the saying, if the P is low, the HO, the null must go, meaning go away. So if the P is low, the null must go. Is our P value low? No, our P value is greater. Our P value 37 is much greater than 0.01. Our P value is greater. It is not low. The P value is greater. So if the P is not low, the null must not go away, right? Remember how that works? So if the P is low, the null must go. If the P is not low, the null must not go away. So the HO, we fail to reject. It's not going to go away. The P value is not low. The null is not going to go away. We fail to reject the null. We're going to keep the null. So that's why we say fail to reject the null. We're going to keep the null. Okay, so then what does that mean? We're going to keep the null. Well, let's go back up to the null. So remember how the null and the HO work. The HO is always weak evidence, and the H1 is always strong evidence. So what are we keeping? We're keeping HO, so we're going to keep up here. Oops, that was not good. Oh boy. It's just such a problem all the time. Okay, here we go. Hopefully that fixed it. and sort of. All right, so right there. All right, so we're keeping HO. So back to HO, and we keep HO. And what does HO say? Mu1 equals mu2 equals mu3. They're all the same. We're concluding there's weak evidence, so they're all the same. And you can see that in the notes too. Well, yeah, there's no more in the notes. So, okay, so again, how do we get to this conclusion? If the P is low, the null must go. If the P is not low, the null must not go. Our P value is greater, 37 is greater than 01. So the null must not go away. That means we fail to reject the null. We keep the null, go back to the null. What does it say? They're all equal. They're all the same. There's weak evidence. HO is always weak evidence. So we believe the evidence is weak and that they're all pretty much the same. In other words, we're saying, yeah, face-to-face, hybrid, online, they're all kind of the same results. Doesn't make any difference. The evidence is weak. They're all about the same. So, okay, so what is, let me write that down. So we're saying weak evidence. And what does weak mean? Instead of using insufficient and stuff like that. So yeah, it's insufficient, isn't it? Weak is insufficient, which means what? Not enough. Not enough evidence. So the evidence was weak. It was insufficient. There's not enough evidence. There's not enough. Okay, and so we go, okay. So then let's come on in here. Okay, so cross out these sufficient ones. It's one of those two insufficient. Is it this insufficient evidence? And so we believe that it is a factor. Well, what do we believe? What was our conclusion? They're all the same, right? All the same. So if they're all the same, does that mean the delivery method is a factor? In other words, whether you take it online, hybrid, face-to-face, whatever? No, they're all the same. So it does not matter, right? If they're all the same, it doesn't matter. So it's this one, insufficient evidence. So we do not believe the coarse delivery type is a factor. We do not believe it's a factor. It's not a factor. It doesn't matter. It doesn't change anything. Has no effect because they were all the same. So if they're all the same, it doesn't matter. If they're all the same, then it doesn't matter which way you're taking them. And so there we go. That's one way ANOVA.